Hi class, so today we're going to be graphing the solution set of two variable absolute value inequalities. While this may sound a little confusing at first, you'll see that we're just graphing absolute value inequalities on a 2D coordinate plane. So let's get started. So when we're presented with the problem as such, okay, we're saying f of x is less than the absolute value of x plus 1, okay? And so I've got a set of 7 steps here, and some of these should look very familiar as we've already done some of these when we were graphing just absolute value equations. Okay, so first step, we want to find the vertex. And so to do that, you're going to set what's inside the absolute value equal to 0. So let's go ahead and do that. Let's take what's inside the absolute value, which is at x plus 1. And let's set that equal to 0. And we'll solve that. Okay? And we end up getting that x equals -1. So my vertex, my x value would be -1. To get my y value, remember guys, we take the entire absolute value equation and we set that equal to 0. So that's going to end up being x plus 1. We're going to put in -1. So we'll say -1 plus 1, set that equal to 0. Well, that ends up being 0 when we're just solving. And so we get that -1 plus 1, 0 equals 0. So my vertex is at -1, 0. Okay? So we did step 1 when we solved for the x. Right? We did step 2 when we solved for the y. And then we're going to set the vertex in the middle point of my table. Remember, we like to do that because that makes graphing easier. Here's where we're going to put my vertex at -1, 0. And then we complete the table. So remember, when you are going down, your numbers need to get larger. And when we're going up, they're going to get smaller. So let's do the numbers as they get larger. So from -1, we'll go to 0, 1, 2. As we go in the other direction, we'll have -1, -2, -3, -4. Okay, and let's start solving. Okay, so when we start solving here, when I'm looking for the absolute value of 0 plus 1, right? So I'm starting off with this 0 point as my x. 0 plus 1 is 1. The absolute value of 1 is 1. When I do the absolute value of 1 plus 1, we get that's 2. And the absolute value of 2 plus 1 is 3. Okay. We learned in the previous lesson that whatever we see coming down this way will be the same reflected this way. So our solutions here could be 1, 2, 3. If you want to challenge yourself, you can go ahead and work those out. But we're going to skip that today for the sake of this lesson. And so we'll complete the table. Now let's graph our points. Okay. So our very first point, we want to start off with our vertex at -1, 0. So I go to -1, 0. Here's my vertex. My next point would be at 0, 1, 1, 2, and 2, 3. On the other side, we'd have -2, 1, okay, -3, 2, and -4, 3. So we've got our points graphed. Now it's just to use the correct line. So in order to use the correct line, you want to pay attention to what inequality symbol we have. We have this less than sign. We have less than. Okay? So when we have these less than signs, you want to be sure that we're using dashed lines. The reason for that is while these points create the line of the absolute value, we don't include these points as solutions. And so we use dashed lines when we draw. Okay, here's my dashed lines there. And my dashed lines here. Okay, so we got that. Now the last part here is we need to shade above or below based off the inequality. So again, we are reading this as less than, so less than, we're talking about all the numbers that are below this, because it's less. So we're going to shade below. Okay. All right, so this kind of combines like a lot of your graphing skills that you would have learned in Algebra 1 as far as graphing inequalities, but we're just adding this to absolute values. So let's do one more together. All right, so for this one here, we want to do the exact same thing. So what's inside to get my 0? This is going to solve for my x version of my x part of my vertex. So we take what's inside, that x minus 5, set it equal to 0, so we get x equals 5. That's the x portion of my vertex. To get my y, I take the entire equation, that x minus 5 minus 2, and I plug in, okay, we said this is equal to y. I plug in what I have for my x, so I'd have 5 minus 5 minus 2 equals 0. Well, 5 minus 5 is 0, so 0 minus 2 equals y, so y equals negative 2. So my vertex is occurring at 5, negative 2. So we got step 1 done, step 2 is done, that was solving for the y. So maybe you might even just start seeing that after you plug in back into the absolute value, that you're seeing your y is usually just your y-intercept value here, like your b value, okay? So you guys might start seeing that a little quicker so you don't have to do all this extra math. Okay, we're going to set our vertex as the middle point of our table. So here's my middle point. We're going to say 5, negative 2. And then we're going to start by completing our table. So if we're at 5, we want to make sure that as we go down, we're increasing. And as we go up, we're decreasing. So if we have 5, then we have 6, 7, 8, and then 4, 3, 2. Okay? And so let's start solving this. So when we start solving this here, we're going to say the absolute value of 6 minus 5 minus 2. So 6 minus 5 is 1. The absolute value of 1 is 1. Minus 2. So 1 minus 2 is negative 1. When we do 7, 7 minus 5, absolute value of that minus 2. So 7 minus 5 is 0. I'm sorry, is 2. The absolute value of 2 is 2. Minus 2 is 0. The next value is 8 minus 5 minus 2. So 8 minus 5 is 3. The absolute value of 3 is 3. Minus 2 is 1. And so when we go backwards, we know that these values are reflective here. If you want to go and individually solve these, you can, but that's not needed. Okay, so we completed our table. Now let's graph our points. So when we graph our points, we're going to graph our vertex first. So we're going to go out to 5. So 1, 2, 3, 4, 5, and then down 2, 1, 2. Here's my vertex. Okay, and I'm going to graph those easier points. So that's 6, negative 1 is here. Then we've got 7, 0 is here, and 8, 1. And then reflected, we've got 4, negative 1, 3, 0, 2, 1. So we've graphed our points. Now we're going to use the correct line. To identify the correct line, we see in the equation we've got greater than or equal to. So we're going to use greater than or equal to, so we want to use a solid line because it's also equal. So we include these points in our solutions. Graph, and then do we shade above or below? We're talking about all the values that are greater than. So these are numbers that are bigger. Okay, so when we talk about the numbers that are bigger, we want to shade above. Okay. All right, guys, go ahead and remember to take your questions on Teams, your Teams questions, and we'll review more of this tomorrow. Okay, guys, have a good day.